Hi, my name is Matthijs Hoekstra and I'm a program manager in the Identity and Network Access Group.
Hi, my name is Rohit Gulati. I'm a senior program manager in Microsoft's Identity and Network Access Engineering. I work on Azure AD verifiable credentials and decentralized identifiers. In this session on Azure AD verifiable credential, we'll talk about troubleshooting. So let's start by looking at the agenda. We'll start by discussing the core prerequisites. We'll discuss some of the common errors that we have seen during our proof of concepts and pilots. And in the end, we'll also talk about troubleshooting tips. So let's start with core prerequisites. To onboard the verifiable credential service, you need an Azure subscription. If you don't have one, you can create one for free. We have called out this link on our public documentation site as well. You need to have Azure Active Directory Premium Plan P2 license. You need one P2 license in your tenant. You can sign up for that for your tenant. And you need the required permissions on the directory you want to configure. Also, you need the required permissions on Azure resources like storage account and key vault. You'll need a PowerShell so that you can create service principal. So we've called out the PowerShell version requirement. And on the mobile device, you will be using Microsoft Authenticator app. So if you're using Android or iOS, we have called out the minimum versions that are required on the two platforms. So let's discuss the required permissions. On Azure Active Directory tenant, you need to have the global administrator or authentication policy administrator permission so that you can access the verifiable credential service blade. And you need to have permissions to do app registration, and you can do service principal creation. On storage account and key vault, the container that you will create for Azure storage that will be hosting the display and rule file, it should have the public access level set to private. And then you need to make sure the storage blob data reader role assignment is explicitly assigned for the signed in user. On Key Vault, for the sign in user, under key permissions, you need create, delete, and sign. For the service principal verifiable credential request service, under key permissions, you should select get and sign. So let's look at a quick demo. So let me connect to my first setup and I'll show you a quick demo on the setup where we'll verify the Azure AD permissions. So on this tenant, when I will search for verifiable credential service and try to access this blade, you can see it's giving me the permission error. I don't have the global admin permission or the authentication policy administrator role assignment to me. So let's look at storage account. For this demonstration, I'm using the highlighted storage account. You can look at the public access level. It is set to private. And if I double click on this storage account, OEA VC hack, if I go to access control IAM, I need to make sure the signed in user has the storage blob data reader role assignment assigned. So I am under storage blob data reader, and you can see I have the right role assignment. Now I'll go to Key Vault and I will go to access policies. Under Key Vault access policy, the sign in user, I need to have create, delete, and sign key permissions. And for the verifiable credential request service, I need to have get and sign key permissions. So that's on the core permission set. Let's look at the Premium Plan 2 license requirement that I called out. You need one P2 license right now in the public preview state. If it's missing or you're using Azure AD free, or if it has expired, you will see these errors. Like you'll see a dependency failure if the license has expired. So let's look at this on our Azure AD portal as well. So let me log into a subscription where you can see I do not have the Azure AD P2 license assigned. If I would access the verifiable credential service blade, I'm clicking on security. I'll click on verifiable credential service,
and it'll pop up at saying that it cannot provision a service principal. So it's looking for a P2 license availability on the tenant. And if you had a P2 license, you had subscribed to trial, but it has expired, the way to troubleshoot that piece is you will, if you go to the verifiable credential service blade, click on the credential tab, you will see the credentials that you have created. You need to look for issue credential URL. You'll copy this URL to clipboard and you will launch this URL on the browser. If the JSON payload opens, that means it's all good. The dependencies are sorted out. But if you get a dependency failure message, fail to open contract, then you have to look at your P2 license. Now, another important thing, you will be creating an app registration. So let's look at that app registration. I will click on app registration and let me open the app registration that I'm using. What I'm calling out, you need to make sure that you have given the API permission to the service principal name. So the verifiable credential request service principal has got verifiable credential create all permission, and you've also granted the admin consent for this directory. So these are some key core prerequisites. Like if I go back to the deck, let me summarize this along with if you are using the sample application. So you need to make sure you have the core prerequisites assigned. You can clone the sample application using Git. You need to have a code editor. You can use Visual Studio Code. .NET 5 is required. You can use ngrok as a free reverse proxy, or you can use any of the reverse proxies you may have, Nginx, Azure AD Application Proxy, or Azure AD App Service, or Azure App Service. And on the mobile device, you need to have the right version of the Authenticator app. Other important things to call out. Please make sure the signed in user has the right role assignment, storage, blob, data reader. I had shown you this demo. Another important thing we have seen in customer deployments, usually the key vault or storage account will be under the private endpoint. You need to make sure all networks is selected. So if I go back to my key vault and I'll go to the networking tab, please make sure all networks is selected, and you should not have private endpoint connection selected. Similarly, on the storage account, if I go to storage account and networking, you need to have all networks selected. These are a few important tips that I thought I'll call out. So here's a quick summary. We've called out the permission requirements for app registration, for the request API endpoint, and key vault, and as well as on the storage account. Now, when you bring up the sample application and let's say you're scanning the QR code, when the authenticator scans the QR code, if you are seeing this error on the authenticator, which says the app or website may be risky, this means that you have not linked your domain to your decentralized identifier of the issuance service. So we have implemented a well-known DID configuration standard specification. So which means that you have to link, you have to create a link between your domain and the DID. That would make sure that the authenticator, when it scans the QR code, it'll try to download that contract. So let's see how do we get this done. So let me go back to my tenant. I'll go to the verifiable credential service blade. I'll go to organization settings. You'll see a section called domain, and you'll see an option to verify this domain. So this blade will give you an option to download the DID configuration JSON file. You can download this and you have to place this file on the server. Please note, Microsoft Authenticator does not honor redirects. The URL specified must be the final destination URL. So that's another important tip. If you don't do this step on the Authenticator app, it'll give a warning saying that the domain is not verified, that you can see it on this blade as well. Another tip, when you are uploading the display file and the rules file on the storage account, please make sure the JSON formatting is proper. If there is some issue with the formatting, you will see the dependency error as well. How would you detect that? As I mentioned, go about opening the issue credential URL file on the browser, right? Now, another tip, if you're using ID token as an attestation flow, the OIDC flow in your rules file, and you have selected some claims in the ID token, and you're not getting those claims in the verifiable credential, my colleague Matthias has documented this experience. Let me just quickly show you using my lab setup. So for the app registration, let me go to the app registration. Under the authentication tab, you will add the web redirect URI, jot.ms. You'll capture the client ID and the tenant ID. And if you see this app in the app registration under token configuration, I have a bunch of claims selected. If in the VC, these claims are not getting stamped, the best way to troubleshoot is to go with this jot.ms redirection, replace the tenant ID and the client ID in this URL. So let me launch that. I have, for the benefit of time, I've created this, and let me launch it on a browser. So I'm going to launch this on a browser. I'm going to log in with an account to see what I'm getting in the ID token. And as it does the redirection to jot.ms, I can see I'm getting country, email, family name, given name as my claims. And that's what I had selected under my token configuration. That's another quick troubleshooting tip.
In this part, I'm going to help you troubleshoot some of the communication between your Authenticator wallet and the Verifiable Credential service. I'm going to use the Edge F12 developer tools. We're going to use jot.ms, and we use Fiddler to capture some of the traffic sent between the server and Authenticator as well. Okay, let's get started. We're running our .NET sample from our GitHub repo here. So let's see what happens when I issue a credential. Click on Get Credential. We call the API, and a QR is generated. I have the browser tools open on the right side, and I can see this URL. What's in the QR code is actually this URL. If this is not specified or you don't see it, but you have another website where you just see the QR code, there's different sites online where you can actually snapshot the screen, the QR code, and decode it here. But this is inside of the QR code. When Authenticator scans it, this will be downloaded. So what I can do here is download this or copy this request and try to download it. I can open the file with Notepad, and you see it's a jot. So let me copy this one. I go to jot.ms. I paste it here, and now I can actually see what's inside its request. It's an ID token, the client ID, open ID, and I am interested in this one. So for example, this is how I can actually find what the contract is. I can open the contract here, and I can see what's in there. Oh, it's going to be a Verifiable Credential card, the logo, the issuer is here as well. There's some self-issue, that means that we are using the ID token hint, etc. That's what I can read from this request. The ID token hint is interesting. So this payload, this issuer request, the issuer actually creates a request with a payload already. So I can open another jot.ms website and see what's in there. I can see the key ID, the DIT from the issuer, etc. the interesting part is this piece. I can see that given name and family name is being part of that that request, and those will be mapped. I can also see the pin code here hashed, and that's what a server will compare it with. When we create the request, the pin is sent in the payload, we hash it, and we have to compare what the user enters later as well. So that's a very quick way of finding what is in this initial request. But how do I find traffic between the wallet and our backend service? That's especially during issuance. So the trick is to use a tool like Fiddler or Wireshark. I have Fiddler set up on this machine. You have to know the IP address. You also have to set up your phone. So what I did in my wireless connection, I did set the proxy server 192.168.1.100 and then the port 8080. So the traffic of the wallet should be captured here. If you go to Tools Options, Fiddler makes sure HTTPS is set up correctly, and you have to install and insert on your mobile device as well, and that you are actually using port 8080 in my case. So what happens if I just drag this one to the side a little bit and say I want to get a credential, I'll scan the QR code. Can you see there's already some stuff happening on the side? I have to enter a PIN code and add the credential. So let's dive into what's happening on Fiddler. And this is my remote machine. First request I see here is that's the request I just showed. You download from that QR code, and there should be a token in there. We just debugged that. The authenticator, the wallet, will resolve the DID. This is how the resolution the DID is done, and you will return a what was the document. It will find a well-known document to make sure you get like this verified tag on top. It does that by downloading the DID configuration JSON file from the domain, and it returns the linked DIDs and it validates that. It downloads the credential, the manifest. Remember, that was in that QR code as well. That's the first thing it downloads after it has done. And again, it has to validate if it's coming from the right domain issuer as well. And after the manifest or the contract is downloaded, the wallet does what it needs to do. In our case, it doesn't need to do anything because it's an ID token hint. And the next one will be a post to the backend server. So let's see what's actually being sent. That is a token. It should be a token. And I can go to Jordanes and paste this token and see what's in there. You can see it's self-issued. There's an ID token in there as well. And it's always nice that you have like Inception with so many tokens. The audience is there, which you can check if it's correct. The public key, given name, and the family name is being sent to the backend. That's what being sent from the wallet to the issuing service, and in return, a variable credential. So that's the result of the issuance request. So again, let's go back to JWT. And now I can see what's being issued. And now let's see the type. It's both a variable credential and a variable credential expert with double T. The first name, last name is in there. The status endpoint where we can check for a revocation, etc. So this helps you figure out what is actually sent from the VC service back to the wallet. The last call you see here is issuance successful with a state. This is being used by the API and will trigger a callback from our service back to your website to show what the end result was of this issuance. Was it successful, or did something happen, etc. I hope this was helpful for helping you figure out what kind of traffic was sent between the wallet, between the website and the wallet and our issuance service. If you have been trying out our Verifiable Credential service, you probably have been running into one of these problems where you issue a Verifiable Credential and you try to verify it, and the wallet shows you this message that that credential has to be added first. And you're very sure you just issued that Verifiable Credential. Or maybe you have a Verifiable Credential in your wallet, you want to be able to verify yourself, but you don't have the credential type, for example. So I'll show you a few tricks how to troubleshoot this issue. All right, let's get to it. So here's the sample app we have. I can get a credential and verify a credential. My wallet is on the right side, so let's get to verify a credential. I scan the QR code. And the wallet says, I don't have that credential. Wait a minute, the Verifiable Credential Expert credential. Well, first thing you would typically look at is, well, did I make a mistake in the press change request? Here's the template, and I am looking for the type Verified Credential Expert. Okay, that seems good. Perhaps I made a mistake with issuance. Let's see, the issuance request. And here's the thing people look at. Look, type Verifiable Credential Expert. That seems legit as well. So maybe I just need to issue a new one. Grab my phone again. Add a credential. Ping. Verify. No. So here's the thing where people, where the confusion starts. This type is actually being ignored. The reason we had this in the past was there was only, we can only issue one single credential of the same type, and we use this to check if you already had it. For now, we ignore it. I'm very sure that the reason this is happening is that the type in the rules file is different than the ones I'm issuing. The problem is if I go to my app settings for my development environment, and I click on the credential, this all looks good. The thing what I don't see here is the credential type I have to specify in the presentation object. I have the rules file here, so I can pretty much double check what I did, and I can see that I made a typo, double T instead of the single T. This is the reason why it goes wrong. The phone asks for a credential. Our service issued this credential with this type since it's in the rules file. You ask for a Verifiable Credential Expert without a double T, and it stops working. So there's a nice little trick you can do to find all the VCs issued to your wallet. What if you change this to Verifiable Credential? I restart my application. When we issue a Verifiable Credential, this type is an array. You can actually create, or in the rules file, it's an array. You can actually issue a credential with multiple types. The system, always adds the type verifiable credential. So if I ask for this type, the phone should actually allow me to choose any of the credentials. So what I can do when I go back to the verifier, create a request again. And now the option is like, oh, well, there's multiple VCs which fulfill this request. Which one? Okay, let me just click this one, allow. And now the payload actually shows me, here's the type. And see there's an array, Verifiable Credential and a Verifiable Credential Expert with double T. So this is a nice little trick to figure out what credential types are issued. If you don't know from which issuer exactly, you can remove the accepted issuers, for example, so you won't get a validation error. But this is the nice little trick to give you the VC type quickly.
To close off, let me share a bunch of resources with you. So the first link talks about our Azure Samples GitHub repository, where you can find samples for .NET, Java, Node, and Python. These samples are using our Azure AD Verifiable Credentials Request API. Then we have a link for our developer documentation, Did for Devs. And the last link talks about how you can set up the verifiable credential service step by step as an issuer or as a verifier or both.
We hope you found this session useful. Thank you for watching.
Thank you for watching. See you in the next video.